Our next speaker is Amr Rafaat, Chief Innovation Officer of Windover Construction. Technology leader and expert in the construction industry's most cutting-edge technologies to streamline project procurement, with more than 20 years of experience combining architectural, construction, and engineering expertise. Amr has more than 20 years of experience combining all of these amazing disciplines. In recognition of his pioneering work in construction technologies, Amr also recently received the Global 2019 Innovator of the Year Award at the Autodesk AEC Excellence Awards. Amr leads Windover's VDC team and the Innovations for Design, Engineering, and Automation, the IDEA platform initiative providing 4D planning, MEP BIM coordination, laser scanning, drone mapping, virtual and mixed reality, prefabrication, robotics, additive manufacturing, and automation to enhance planning, scheduling, site logistics, and safety throughout all construction phases of Windover's projects. I think you got a big job, Amr. Amr received his master's degrees in architecture from the Boston Architectural College. And a fun fact about Amr is that he has earned his black belt in karate when he was 16 years old. In his free time, Amr enjoys traveling to historic places with his family, and he currently lives with his wife and 2 young daughters in Lexington, Massachusetts. Please welcome Amr Rafaat.
Hello, everyone. Excited to be with you today in this building, the Tech Center. We've been here residents for 5 years, actually more, a little bit more. And here I consider it a hub for innovation. Here we have built collaborations and partnerships and friendship with so many innovators from different industries, from manufacturing, folks that we wouldn't be working with, from Australia, from New Zealand. And I'd like to give a shout out to the Howick team, who is really bringing all these great folks together, pushing innovation every day on the work they do. So I'd like to introduce a little bit about Windover Construction. We based in Boston. We build everything from schools, academic, life science, commercial, multifamily, residential, and we are really the go-to in New England for modular construction. We have built over the years this great expertise in-house with superintendents, project managers, and technology team that can push innovation and make sure there are certainty of outcome for modular construction. We have launched it 3 years ago, the IDEA platform, which stands for Innovations for Design, Engineering, and Automation. We wanted to extend our technology and leading edge services to a broader spectrum of folks in the industry. We work with architects, peer group, construction companies, and manufacturing around the globe right now. We worked with Amr, one of the biggest developers in Dubai. We worked with Hickory in Melbourne, Australia, and around the US with laser scanning, drone surveys, BIM coordination. And that we thought that's our platform to help push and provide and extend our services to everyone. I'm going to go through real-life examples of how we are pushing innovation throughout the life cycle of our projects. These are real examples with schedules, tight schedules, and budgets, and how we are utilizing innovative solutions along the way to build more efficient. This is a project in Somerville, which is about 30 minutes from here. This is what you're seeing here is a standard for our work. When we start any project, whether it's modular or traditional construction, we start with a 4D sequence. We do it in 3D Max. So what we do is that you have linked with the schedule key milestones. What this helps us is understand the site constraints. When we bring those trucks with these modules, how we're going to fit them, safety planning, logistics planning, identifying discrepancies and clashes with existing utilities. So that's the best practices when we bring these off-site elements, how we're going to fit them on site, in addition to syncing to schedule, to set expectations between not only our trade partners on site, but also the client and the city. This is a great tool to communicate with the city. What you see here is a drone mapped scan, by the way, of the site, and not a model. Now into that collaboration with between Autodesk, Howick, Structsoft. What we did is that we had this 120-year-old building, which we figured that the ceilings for that building, a really old building, is not even. So what we actually did is that we came up with an innovative solution together. This is Structsoft. What we did is that we laser scanned the building, figured it out, worked on the onyx, and what you will see here, what the power of the telescopic technology is that it can actually fit within, it can travel very small, like small Lego pieces, and when it goes to its intended location in a building, very tight elevators, very tight corridors, it can maneuver through the spaces. So when it goes to its intended location, it can expand and fit with any spaces. What I call that adaptive industrialized construction. It can adapt with any geometry, and that cut a huge time saving on site without having to adapt and cut on site. It really increased safety on the job site as well. The power of this technology really is how it can adapt with our existing. It can work for our life science projects. You can fit out spaces very quickly, isolate areas. It can work with any fit out that we wanted to do with increased efficiencies. As you see here, we did it at the Autodesk Technology Center. That was our factory. A really amazing team, and we assembled these pieces, and when it travels to the site, it goes and expands. As you see here, it goes very small. We're actually working on a project similar right now. You see it goes maneuver within tight corridors, goes to really small elevators. It can really apply to any existing condition site. And when it goes to its intended location, it expands. This is very powerful for our field team. Really loved this because it's a really making their job safer and much faster. And what I really like about this technology overall is that it's very green. There is no much waste in the material you produce when you use the Howick machines. This project also had a challenge. We had to rip off most of the inside and add new steel elements. So how we make sure those steel beams that's being made miles away will come and fit perfectly within that existing structure to remain. What we did actually is that we laser, you see that point cloud in Autodesk Recab and in Revit, we laser scanned the existing structure to remain, the facades, and we did QA/QC overlays with the beams for the steel to make sure that when those steel beams will come, will fit perfectly within the structure to remain. Another project we worked on here is at Tufts University. This is modular. What we did is that getting involved early on the project, we've been helping them test fit how these modules will fit on site. As you see here, it's all the studies. We scanned the existing utilities on site to make sure that we can coordinate it very well in a very short time to deliver that project and towards certainty of outcome. So this early modeling and test fits is really important when we start working with the factories that making the modules to set expectations and working along with the design team, of course. This project needed almost 1,000 trusses, 935 trusses for the roof. What we actually did is that we collaborated with Autodesk and with Stud.io. We actually were able to create almost 1,000 trusses in 15 hours only using the Howick machine. So much efficiencies out there. And then for years, we've been using mixed reality to view how buildings will look like in the future. But for this one, we collaborated with Hologram in Australia, and you see how these collaborations being built in here at the Tech Center. Worked with them, utilized their leading edge mixed reality solution using the HoloLens. So you can, guys, it's like assembling IKEA furniture without having to look outside of the task in hand. It increased efficiencies, so they don't have to look outside. With that, we were able to increase efficiencies in assembling it, and it also brought so much fun on the job site. When our field team, we empower them with these technologies, it really enhanced safety, efficiencies, and bring the fun to the site. We actually used additive manufacturing here at Autodesk. This is a historic 120-year-old building north of Boston. The facade was originally done in plaster. It was falling apart, and the client asked us to renovate the building and renovate the facade with the most efficient budget we can and the highest quality you can. So what we did is that we laser scanned the facade, and we created a detailed Autodesk Fusion model of that to the millimeter accuracy, because you carry over versus the traditional methods. You carry over all the laser scan data, and it carries over in the model to create exact replicas of these pieces. We're able to 3D print some of these elements using the 3D printer here at Autodesk. using additive manufacturing, and it used a recycled material that would stand for another century with no maintenance needed. As you see here, it's also lightweight, very accurate. This is exact replica of how this facade looked 100 years ago, and everything above this column line was digitally prefab using a 5-axis router, beautiful small rosettes that was done by hand 100 years ago. We're able to create the exact replicas of them using digital prefab. So that's another way of how we can tackle the challenges of shortage in labor, skilled labor. We don't unfortunately have the folks who can really do this by hand, and even if we do, it's not going to be very cost effective. It's going to take a long time. With that, in hours, we can create exact replicas of that, again, using laser scan reality capture combined with additive manufacturing. This is another project of how we can provide certainty of outcome for project. This project won the EEC Excellence Award in 2019 for transforming how we coordinate modular construction on a job site. It's in Beverly, Mass. It's architected S3 design. And what we did actually is that this is another 4D that's best practices for us, help us plan projects early on in the process with the key milestones, help with the city. The challenge on that job was that it has a podium of steel in the first 2 floors. This is how it's built. The scale of this is huge. You have 2 buildings, building A and building B. And the challenge for that job is that you have a steel structure at the podium and the modular construction above. As a challenge of any off-site construction projects, you want to make sure that these off-site constructed elements or boxes will fit perfectly above, the vertical shafts will fit perfectly above the as-built components. So we want to make sure we coordinate between as-built steel, not only drawing steel. So after the erection of each steel phase, we laser scanned those steel and we did QA/QC overlays in real time, and we communicated in real time again with the factory in Canada who is prefabbing those boxes, and we told them, hey, your vertical shaft for MEB will hit steel by these 2 inches. Can you edit them here? And then we were able to make sure when those boxes arrive, all these vertical shafts with MEB will fit perfectly on site. That's certainty of outcome using laser scanning. This is another way we use the Autodesk software innovatively. This is Autodesk Civil 3D. For years been used on a flat surface when we drone a site or capture with a survey a site you created on a topo. What we did is that we flipped it as a facade. We're able to detect the blumminess of that facade using the laser scan data, so we can communicate again in real time to the facade folks how this facade is behaving after we placed all these boxes, so they make sure when they put the facade elements, we preserve the design intent and make sure everything will be smooth. This is a finished, beautiful project in Beverly, Mass. This is a project at Dartmouth College. This beautiful terracotta is coming from Spain. The glass was coming from Germany. It's actually built upon a structure to remain that is actually a 1970 building, I think. What we did is that after we stripped off all the details of that building, we actually laser scanned the whole structure to remain, and did QA/QC with overlay with the design drawings and communicated, hey, that building 30-year-old, that structure 30-year-old is not a perfect square. Then communicating these a little bit discrepancies with the design teams, you're able to adjust the drawing, so we make sure when these facade elements arrive on site and being fabricated off-site, when they come there, it's going to fit perfectly on the existing structure to remain. The constant communication and QA/QC using laser scanning reality capture with BAM is really key here. This is another example. We collaborated with Autodesk Takeoff, great friends of ours, in using models from design drawings to expedite the quantity takeoff process. Details, virtual mockups is very important early on to make sure how these preset pieces will put together on the field. It helps communicate with our trade partners on site. This is QA/QC overlay. It became, whether it's a modular construction job or a traditional method job, building it with any other method, it became a standard for us to do this. After we put QA/QC overlays, after we put all the underground pipes, we laser scan, whether with the LiDAR drone with ground control points, or a laser scanner on the ground, we laser scan those pipes, vertical risers, and they do QA/QC overlays to make sure every pipe on the underground will meet its intended location on the first floor. Imagine that's before we pour concrete, because once you pour concrete, it's really hard to break onto these, cause delays. So that's the whole purpose of our work as a technology, tech-first solutions, is really to make sure no surprises on the job site. That's the whole purpose. This is a beautiful building that came out in 8 hours on site. There is a time lapse into it. It was assembled on site with modular construction in only 8 hours. One of them, there was a nice time lapse for it. This was during COVID, and all these trucks coming from Canada with boxes really needed to finish the job within a day or 2 days at most. So what we did is that actually to do certainty of outcome, after we put this slab, we had to confirm the flatness of this slab is that it is within half of an inch. How we do that? Again, laser scan of the site of that slab, and in Civil 3D get spot elevations and communicate that in real time to the field so they make any necessary adjustment to make sure of that. That's a twin build. We use it with our friends in Australia. It's got these codes, bring the accuracy to really good accuracy in there using those codes, and we use it for pre-assemble, like you see that millwork when it's getting prefab outside. This is an innovation space that we built at the Belmont Hill School. As you see here, we wanted to communicate and overlay the 3D models for coordination purposes in the actual space to make sure everything will fit perfectly when it arrives there. And we use it for MEB systems as well. And finally, this is a collaboration that we're doing with Autodesk Tandem team. Windover right now is building with Blueprint, will be the biggest mass timber projects in North America. It will be in Connecticut, and Windover is a CM. What we actually did is that we started from now, and we did it at PE as well, building that Autodesk Tandem model. What it is allowing us, after we finish many projects, or 90% of our projects, we end up with a fully coordinated Navisworks model. And then at the end, it sits on some one computer. What we're doing is that we're empowering our client, who is not an expert in BIM, that they can use that years to come and use this data at their fingertips with their iPad, with their computer, to really monitor the building. We are adding IoT sensors at Phillips Exeter Academy. They have all the O&M manual data, so they can really support the future facility maintenance and management. This is information-rich data that at the fingertips of clients who don't really need to be experts in BIM. And it's really transforming our handover process, which for years been about books that no one wants to really read it, okay? So this is very easy to use, doesn't require any training from any user. We used it at Phillips Exeter Academy. It's been a success story. They loved it at the facilities team there. And one more thing, we're collaborating with Stud.io, the LAD team, Howick, Autodesk, and Hologram, our friends from Australia. They wish they were here. This is really about exploring new ways and redefining what we can do with light steel gauge, taking a new, fresh ideas and try to apply it with different technologies. As you see here, using Hologram to assemble it, using amazing Stud.io, StudFinder software that's compatible with all our softwares we use every day. It's really redefining what is possible. The most important thing that we really need to focus on is using technology to really offer solution for the challenges we have every day on job sites, and it's a collaborative effort between a superintendent on the site, project management, technology group, great folks like Autodesk pushing the industry, and manufacturers like Howick. All together, we can really advance our industry together through these collaborations. Thank you so much.
Fantastic, Amr. Any quick questions for Amr?
The question is, how much does the scanning impact the production facility? Meaning, the premises in the offsite, things start way ahead before the on-site itself. So if you're scanning and there's a module being built or multiple modules and a shaft changed 1.5 inches, how is that synergy going on?
You're bringing up a great point. That's why you found me saying real time all the time. Because in the canvas example, while they making the boxes in Canada, with our partner there, building the boxes, we communicate this information in the same day. The power of the laser scans, you can, in Autodesk Recap, process all this data in like half an hour or an hour, do all these QAC overlays, and have a quick Teams call with the factory and tell them, hey, that's what we found on the steel on the site. So the key is real-time communication. If you give them this data 2 days later, not good. They not really use it. So the power that's empowering us really now, laser scanning technology really advanced with LiDAR drones, is that you can process data very quickly and communicate that very quickly to the factory in real time so they can make the adjustments according to the findings.
As the construction manager, do you have some kind of a buffer on your schedule to account for those things? Because I know all it's going to come down to liabilities and delays and all kind. You know, it's I'm the fabricator in that supply chain, right?
Yeah.
So who's the one to blame, right? If things goes wrong.
Oh no.
So right now, first of all, the laser scanners we use Faro laser scanners get calibrated all the time. It's you have to trust. It's one of the best scanners that we use. Its accuracy is within 1 to 3 millimeter. That's what we use. Also, we process it in Recap. But here is the thing. Right now, we see it a collaborative effort. It's not like you or me. We all assisting each other to find discrepancies early, so we do the best we can to avoid any surprises or delays on the job site. So as I said, it's all about bringing up a great point, Dave. It's all about combining different technologies. You have reality capture, which include drones and laser scanning. You have the BIM, which you do the QA/QC overlays. You have the prefab factory who really know how to fix these things on their end. And you have the design team who is really forward thinking and providing these design models to us. So it's really accessible when all these partners work together in an open, transparent environment, a really collaborative environment, so we can really make this work.